Hello, my name is Sarah Waterman, and I'm doing my presentation over Pythagoras and ancient Greek mathematics. I would really like to dig deeper into the history of Greek mathematics and what was happening in Greece when Pythagoras was alive. I believe knowing the culture and the larger events of this time would help us have a better understanding of Pythagoras. The main point of this presentation is to inform you so you can make a better decision on if Pythagoras was the mathematician we all thought he was when we learned about him and the Pythagorean theorem in high school. After I am done discussing each slide, I have put 5 seconds in so you can get all your notes together before we move on to the next. I would like to start with the culture of Greece when Pythagoras was alive. He lived during the Archaic period that lasted from 800 to 479 BCE. There was a lot of growth in the population during this time. Having more people in Greece meant more trading and selling. Since there was so much commotion happening, people began to colonize. With all growing populations, we begin to see different kinds of people. All people come from different backgrounds. With different backgrounds become different ideas, religions, celebrations, and culture. People will begin to adopt new ideas from their neighbors and may even create new ideas. This could be a good reason as to why the Archaic period had many advances that would be remembered for a long time to come. One of the newer ideas that began from this colonization would be democracy, very similar to the one we know of today. Like most civilizations during this time, people of wealth were the ones that held positions of power. There is a large development in the field of Greek literature, and the first Greek alphabet was developed. The earliest Greek writing had been dated to 750 BCE. The Persian Wars began during this time, and it started with the Ionian revolt of Greek colonies in the settlement in Asia Minor from Persian Empire. I provided a picture that has the Asia Minor to the right of the map. Now, Greek mathematics was heavily influenced by Egyptian math, especially the theory of right-angled triangles, and also they try to tackle a lot of age-old mathematical problems that the Egyptians could not solve themselves. Greek mathematicians at this time had many advancements that has affected all subjects across the world that we know of today. Many of these subjects include geometry, engineering, astronomy, and design. Greek mathematicians also provided many fundamental math and science ideas and proofs that we still use today. We try to build off of these or refer back to these proofs that they created. Mathematicians also realized that deductive reasoning became very important because it was incredibly successful in their math. Now, observation was less likely to be used during this time because of deductive reasoning. Other disciplines began to realize how successful deductive reasoning was for mathematicians, so they began to do deductive reasoning as well. If you can't remember what method this is, it's when you start with a general statement or hypothesis, and then you examine all the possibilities to reach a conclusion. I have added a picture in the bottom right corner, and it has the symbols that they use that would correlate to the number values that we use of today. I have added a video onto the next slide that discusses more about Greek mathematics and the mathematicians during that time and how their findings and proofs has affected our world today.
Around 2,500 years ago, a group of revolutionary thinkers changed the way we think about mathematics. Through the idea of proof, the ancient Greeks showed that maths isn't just about performing calculations, but a way of understanding and testing the reality of the world around us. The sign above Plato's academy was said to have read, "Let no one ignorant of geometry enter here." And the great Archimedes was even killed by a soldier because he refused to leave a proof unfinished. But what is a proof? Simply put, a proof is a convincing argument to demonstrate whether something is true or false. For example, if all dogs have 4 legs, then is this a dog? It's easy to prove that just because all dogs have 4 legs, not everything with 4 legs is a dog. How about a mathematical proof? You probably heard of Pythagoras' theorem, a mathematical fact about the sides of a right-angled triangle. Here's one demonstration of the theorem. Does it convince you? Good proofs are undeniably true. 200 years after Pythagoras was around, another Greek mathematician called Euclid perfected the way to write proofs. with just a few basic assumptions known as axioms, Euclid was able to prove many other mathematical results. He compiled these results into one remarkable book called The Elements, and his proofs are as true today as when it was first written, and have formed the foundations of modern mathematics. From proofs about infinite prime numbers used in internet encryption, to mathematical formulae used in engineering, the ancient Greeks have provided scientists, economists, lawyers, architects, and well, just about everyone with a new mathematical understanding of our world.
As I stated earlier, Egyptian math was very influential to Greek math. Now, during the 26th dynasty of Egypt, which was from 685 to 525 BCE, the ports of the Nile were finally opened to Greek trade. Now, I'm sure it's easy to understand how these two cultures were able to intermingle because they were sharing the same main water system. Now, many great minds and a lot of scholars from Greece would leave and go study in Egypt, especially the discipline that they were interested in, and they would come back to Greece with new skills and ideas, and they would try to build off of them, and they would probably take credit later on. We would probably be able to notice a lot of these names that did go to Egypt and came back to Greece, and these include Thales and Pythagoras. One of the ideas that Greece took from Egypt was the right triangle ratio. Now, this is known to us today as the Pythagorean theorem. Now, Egypt was not the only influence that Greece had at the time. One of the other influences mainly happened in Ionia, which also had an Egyptian influence, but was exposed to the culture and ideas of Mesopotamia through its neighbor, the Kingdom of Lydia. Now, I showed you a picture of the Asia Minor, and this is where Ionia was located, and it's also known as Turkey today. This was one of the most important centers of the Greek world at this time. Greek was also notorious for conquering areas, and when they conquered these areas, they took in the ideas, and they learned about the cultures, and then they took what they thought was beneficial, took them back to Greece, and they profited by putting them under their name as Greek findings. An example I can provide you is about Alexander the Great when he conquered the East. Now, there was astronomical knowledge that they found that the Greeks get credited for, but it was from the Babylonian and Chaldean culture. Some of these ideas that the Greeks found were also mathematical tools that they built off of or just simply used, and this helped advance the Greek math that they already knew. Now, one of these examples is the numeral system base 60, which allowed the Greeks to divide circles into 360 degrees. And it is finally time to discuss the man of the hour, Pythagoras. Now, I can't talk for everyone, but I know whenever I was in school, the only time I heard about Pythagoras was whenever we were discussing the Pythagorean theorem. Now, without any knowledge about Pythagoras, besides the theorem that they were teaching us, I made the conclusion that he was a great mathematician. What I will be presenting from this slide on will probably help shape our ideas on how we think Pythagoras really was. Was he a mathematician, or was he a philosopher, or maybe both? So although many people would probably consider Pythagoras as a mathematician today, back then he was considered the first Greek philosopher. He was born on the island of Samos in 570 BCE, which was right off the coast of Turkey that we know of today. Now, his entire life was spent during the Archaic period because it was 800 to 479 BCE. Most of his young years were spent studying in Greece. Now, he fled southern Italy to escape the harsh rule of Polycrates. He traveled to Egypt during this time, and he studied in Egypt. During his time in Egypt, he noticed the right triangle ratio that the Egyptians had found. Before we dig deeper into the life of Pythagoras, I would like for you to take out a piece of paper and a pen, if you haven't already, and write down whether you think Pythagoras is a mathematician or a philosopher. You could write both if you want and try to give a quick explanation as to why you think this. I would like to see how your view changes from this presentation at the beginning to the end of the presentation. I will give you about 20 seconds to think and write this down. We had learned in class that the Egyptians' documents had not been preserved very well over time, so we only have about 100 documents to look back on. What I did find was a lot of Greek people and how they discussed how the Egyptians were very practical in their math. And when I mean practical, they all knew how to use the math, but they really didn't dig deeper into understanding how the math worked and why it worked. As I stated before, Pythagoras was a philosopher during this time, but he was a philosopher that really loved his numbers. Now, Pythagoras saw this right triangle ratio and he wanted to analyze it. While analyzing the right triangle ratio, Pythagoras noticed something that the Egyptian never had noticed before, and he did this by stretching the right triangle to its logical limit. By doing this, he triggered an intellectual revolution. This is now known as the Pythagorean theorem that we all know of today, a squared plus b squared equals c squared. Pythagoras is credited to having the first proof for this problem. Now, we're not quite sure if this was Pythagoras that wrote the proof or one of his followers. A question that arose whenever I read this was, how do we know 100% that Egypt did not have this proof to begin with? If most of their documents were lost and only a few were kept and that we can look off today, and Greece was kind of notorious for taking other cultures, other ideas, and making them their own, how can we trust that it wasn't Egypt that found this first? How do we know that Pythagoras just didn't take it and put his name on it? Pythagoras was still in Egypt when it was attacked in 525 BCE. Usually this would be very unlucky for people, but for Pythagoras, he was very lucky. He was taken as a prisoner of war to Babylon. Now, they saw that he was very intelligent to start off with, and they figured, you know what, he's way too smart to be a slave. So he was told to go to the Babylonians and teach his knowledge. While Pythagoras was teaching the Babylonians, he was taking his own time to study the ideas, the culture, the theories that the Babylonians had. Pythagoras had gained a lot of knowledge from the Egyptians and Babylonians during this time. So, he had a lot of time to reflect on his philosophy and to build his ideas for his new philosophy. The Babylonians did have tablets which had connections to Pythagoras' theorem. Because of this, they were familiar with Pythagoras' theorem. I will be reading a translation from a Babylonian tablet which is preserved in the British Museum, and it says this: 4 is the length and 5 is diagonal. What is the breadth? Its size is not known. 4 times 4 is 16. 5 times 5 is 25. You take 16 from 25 and there remains 9. What times what shall I take in order to get 9? 3 times 3 is 9. 3 is the breadth. That sounds very similar to a squared plus b squared equals c squared. The example they gave on the Babylonian tablet was a 3 to 4 to 5 ratio. We can now ask the question, who should Pythagoras' theorem actually be named after? Egypt, Babylon, Pythagoras, or someone else out there in another culture? Now I will discuss an example of the Pythagorean theorem and what we would like to solve for x. Now the triangle has 3 sides, and the sides are a equals 12, b equals 9, and c equals x. The equation for Pythagorean theorem is a squared plus b squared equals c squared. We're now going to plug in the numbers 9 and 12 to the equation and get 9 squared plus 12 squared equals c squared. We will now square 9 and 12 to get 81 plus 144 equals c squared. Add 81 plus 144 together to get 225. And we're going to square root 225 to get c by itself. And the answer is 15 equals c. After looking at this answer, you will see that it's still a 3 to 4 to 5 ratio. This holds true to the Egyptian, Babylonian, and Pythagoras theory for the Pythagorean theorem. Pythagoras spent 5 years in Babylon and then returned to Samos. He established a group called the Semicircle of Pythagoras, where he would discuss his ideas that he was exposed to while he was away in Egypt and Babylon. After 2 years, he moved to Croton in southern Italy, where he founded a religious and philosophical school. This school would be very important to how Pythagoras was remembered because of this. His inner circle were called mathematicians, his students were listeners, and all followers were called Pythagoreans. Now, the Pythagoreans really paid attention to Pythagoras and what he said and took everything that he said to heart. They changed their lifestyles to fit the way that Pythagoras thought. Pythagoras did not believe in a god. He believed that numbers were the answer to everything. He believed that numbers created a cosmos that we lived in. The Pythagoreans also agreed with this, and the basis of it was that after you die, your soul is immortal. Your soul will always reincarnate into an animal, a plant, or something else. There is actually an account of Pythagoras saying that he was walking down a street and heard an old friend from a past life yelling from a dog's bark that was getting beaten. Pythagoras also sat and discussed times that he remembers what happened in his past life, and he would apply it to his new life and continue it to each life that he goes to. As said before, the Pythagoreans were the people that followed Pythagoras and his ideas. The main thing that they wanted to teach was dualism. They believed that opposite forces is what controlled life. Odd and even were equal to the limited and unlimited. The opposites that they found were most important were right and left, male and female, motionless and movement, straight and crooked, light and darkness, good and bad. Pythagoras thought that numbers can solve any problem in the universe and that spheres were the shape of all planets including the Earth because the sphere is the perfect geometrical shape. Pythagoras thought that the Earth was the center of the cosmos that was created by numbers. We have found that Pythagoras never wrote anything down. He more just gave speeches, and then people would publish things after hearing him about Pythagoras. So this arises a question as if Pythagoras actually created the first proof for Pythagoras' theorem, or if it was one of his followers. Growing up, Pythagoras learned how to play the lyre. This is where he became very interested in music intervals. If you're not sure what music intervals are, it is do, re, mi, fa, sol, la, ti, do that we know of today in our music. Now, he found that the chief intervals can be expressed in numerical ratios between the first 4 positive whole numbers. This is where Pythagoras became fascinated with the number 10 and the theory that the number 10 and the sum of 1, 2, 3, and 4 embraced the whole nature of numbers was created. Now, if you look at the Pythagoreans, they have this triangle that they follow, and it has 1 dot at the top, followed by 2 dots, 3 dots, and 4 dots. And this represents the addition of 1, 2, 3, and 4 that has a total sum of 10. This is known as the tetracycles of Decad. As I said before, the Pythagoreans did not worship any god, but the tetracycles of the Decad was such a powerful number in the Pythagoreans' eyes that this is the number that they swore and did oaths to during religious ceremonies. The square root of 2 is known as the first mathematical crisis. The Greeks were very confident when it came to square roots of numbers, but the number 2 really left them in confusion. They tried and they tried and they tried to find the square root of 2, but nothing seemed to work. I have added a statement that says, if we had a square with each side a unit in length, and we also had a second square with double the area of the first square, how would the side of the second square compare to the side of the first square? The square root of 2 is an irrational number, so it cannot be expressed by any simple fraction. This is why we are able to find the answer today, but the Greeks were like the Egyptians when it came to fractions. They really enjoyed using fractions anytime that they could. This is why they could not find the square root of 2 in a very long time. They tried for a very long time to make sense of this problem that they could not solve. Because they could not solve this, Pythagoras tried to keep this a secret within the Pythagorean brotherhood. This created a crisis in the roots of Pythagorean beliefs because of the fact that numbers were supposed to be the solution to everything. They finally have a problem that they're trying to solve, and they cannot solve it using numbers. Since Pythagoras could not leave this unsolved, he came to the conclusion that no ratio of two whole numbers could express the value of the square root of 2. This is where the brotherhood becomes more interesting, because someone wanted to let the secret out of the Pythagorean brotherhood, and people found out, and they took the traitor and they threw him in deep waters and they drowned. And the one member is not certain who it was, and this is just an account, and it's not extremely historically accurate, but many people believe that this is what happened. This is also known as the first martyr of science, but a lot of people deem this as more towards religious instead of science, because it does seem kind of like a cult. I added a picture from the Ancient History Encyclopedia next to the notes, and it's a very good example of what the Pythagoreans did for the square root of 2, and the title is Method of Approximation of the Value of Square Root of 2 used by the Pythagoreans. And here's a description. You set up two columns of numbers, A and B. The first number in each column is number 1. The next A number is formed by adding the last A and B. The next B is formed by adding twice the previous A to the previous B. Now the chart has columns A and B, and next to that is the comments, and it reads, in each pair we can see that 2a squared minus b squared equals 1 or minus 1. Therefore, b of a is a fairly good approximation of the value of the square root of 2. In each step, the value of b over a gets closer to the value of the square root of 2. 99 over 7 is already an acceptable approximation to the square root of 2, since 99 divided by 7 squared equals 2.000206. For the value of the square root of 2, the Egyptians used the approximation 7 over 5. We know Pythagoras due to his theorem, and he also followed the Greek tradition when it came to his philosophy. During his time and around 150 years later, he was most famous for 4 things. The first is he was an expert on the fate of the soul after death, and he thought that the soul was immortal and went through a series of reincarnation. He was an expert on religious material. He was called a wonder worker who had a thigh of gold and who would be 2 places at the same time. He was also a founder of a strict way of life that emphasized dietary restrictions, religious ritual, and rigorous self-discipline. Based on the evidence of the Tractate of Decad, his Pythagorean theorem, and a lot more theories, he shows that he valued relationships between numbers. Pythagoras was mainly a philosopher during his time. Again, he appreciated numbers a lot, and a lot of his theories dealt with numbers, but does this make him a mathematician? Now, if you look up mathematician in the dictionary, it reads an expert in or a student of mathematics. Then you can look up the definition of mathematics, which is an abstract science of number, quantity, and space. I believe that Pythagoras showed a lot of knowledge about numbers and knew how to manipulate them, so I feel like that he was both a mathematician and a philosopher. I'm not quite sure if he should be the one that should take credit for the Pythagorean theorem because of the Egyptians and Babylonians at the time, but that's not always 100% given because I was not there at that time. I would like for you to reflect back to whenever you first answered whether you think Pythagoras is a mathematician or a philosopher. Now, take about 10 seconds to think about how you view him now. Hopefully, some form of your idea has changed because of the knowledge you have learned throughout my presentation. I think Pythagoras was definitely a big public figure, and he was still a philosopher and a mathematician in some aspects.